So welcome. This is our talk on how not to build a Kubernetes cluster. Got a clicker, but pressing the buttons anyway. So I'm Tristan. I'm an infrastructure engineer at BookingGo. This is Mike. He's my team lead, also at BookingGo. Has anyone heard of BookingGo? Yeah, great. Has anyone heard of rentalcars.com? Okay, so there's a few. So BookingGo was always since 2010 has been part of the same company as Booking.com. We merged this year or last year, and our target is basically to do ground transport for Booking.com. So we're part of that now, but less about that, and moving on. So, great. The infrastructure at rentalcars.com as it was a very sort of traditional infrastructure, which a lot of you will probably be familiar with in a commercial sense. So we had VMware and Puppet. It was pretty bad. We had a small team of engineers, and it was kind of manageable, but it was very hard to scale out and very hard to improve rapidly. Microservices arrived. This is some of our complexity. I'm not really sure if you call this microservices, but we're going to pretend that it is.
That's an actual picture.
That is an actual picture, yeah. That's an actual diagram. It's not just off Google. And all of a sudden it became unmanageable, and you had up to a 6-week lead time just to get some VMs out the door, and now you need 10 VMs. So your product becomes the first one, and under the hood you have progressively worse manageability of all your services. So naturally, we decided to implement a new infrastructure. How do we manage it? How do we migrate to it when you're coming from a VMware world? Which was free VMware or ESXi as well. We didn't really have any cloud native skills within the organization. And so the question became, do we just license vSphere and sort of get DRS and all the niceties that come with that? But we didn't really want that. So Mike here wanted to look at something that we could use in-house that would be free, and we could hopefully use something like Terraform with it to reduce the lead time and get services up quicker. So this was 2016, something like that. So quite late in the game. So we trialed some new technologies. One of those being OpenStack. So we tried a few cheeky installers of that. And in the meantime, this thing called Kubernetes came out and started making ground quickly, which was something that everyone was talking about. And in the midst of it, we also tried OpenShift. But we weren't really sure which direction to go, because there was a lot of noise saying that maybe we don't need OpenStack, maybe we don't need the whole infrastructure as code process, and we can just move straight to orchestrated containers and do it that way. So the plan at first was to put Kubernetes on top of OpenStack, but considering we had no cloud-native skills, the idea of putting complexity on top of complexity did scare us a bit. But as you can see, we tried quite a few technologies. And eventually we got the green light to give it a real go. But we did decide to just do bare metal Kubernetes. So we came up with this beautiful thing here, which is a C7000, or a rack with or C7000s in it. We could have 2 of them, maybe 3. We've got some solid fire, cheeky SSD storage at the top, and we decided to use KubeSpray for bare metal provisioning with Foreman to be our inventory. So the process kind of looks like this, or looks like this. Bamboo was our CI tool that was just in-house at the time. So we decided to look at that, to use the Hammer CLI, which talks to Foreman API, and eventually we provision servers, then provision Kubernetes on top of those servers with KubeSpray, and eventually we get Kubernetes. So the process, which is important to note, kind of looks like this. So using Ruby and Hammer, we'd get the hosts via a host group, which we had. So we'd have dev, test, and prod. And then we'd schedule a rebuild. And eventually, using VMC and ILO, schedule it off, it would rebuild all of the servers, and then we would run Kubespray, again using Bamboo. And things were pretty good. We had teams being enrolled onto the new Kubernetes platform. Everyone was getting pretty happy with Kubernetes. We were using more resources. We started using things like secrets and things like this. Everyone was pretty happy with it, realizing the potential. And we did have a few issues around C groups. We were using CentOS. Now found out that CentOS is a terrible thing to run Kubernetes on because of some weird kernel patches that they did put in themselves. So you just getting resources, or nodes would get CPU lookups because the C groups weren't actually managed properly. So you just get nodes dying, and you'd have to go on and reboot them through an ILO. But apart from that caveat, things were generally pretty good, and we're in a good space. And then, so as I mentioned, we're using Foreman to do our whole inventory. This was coming from an in-house tool that was written by our bigger brother, Booking.com, called ServerDB, which was written in like Python 2.5 in 2000. I don't even know what year. It was old. It's old. We still use it internally because we decided Foreman wasn't the tool to go to. Mainly because of this. So we'd built up all this trust and this value within the company. And then this bug came along on the version of Foreman that we were using. So as I said before, we got all the hosts through a host group. And essentially there was a bug in the Foreman API that meant that if the host group was empty, i.e. for whatever reason that environment variable in Bamboo wasn't populated, that it would return every server in Foreman. So when we went to rebuild one of our clusters and do a new upgrade through Kubespray, what that ended up doing is rebuilding every single server in Foreman. So all the trust that we've just gathered all of a sudden becomes, oh, why is this node rebooting? Why is this node rebooting? And all your clusters that you've had built up and people are now running code on are rebuilt. So the process actually looked like this in this case. So Bamboo gets all the hosts for your host group, but because that was empty, it actually returns all the hosts. And yeah, we ended up rebuilding all of our infrastructure that we had in Foreman. Now, at this time, it was still kind of proof of concept stage, thankfully. So we only had a few servers in there, mainly being Kubernetes. But if we'd carried on along this path and hadn't found this bug yet, we would have kept promoting or had, promoting as we had in the business to input your servers into Foreman, and it would have been a lot worse because the estate is something 2,000 servers, I think, a mixture of VMs and so on. So thankfully, we kept our in-house version of ServerDB, which I won't show you because it is quite horrific. So it became a bit like this. And managing that was pretty good. But there started being some noise around hosted, managed Kubernetes services. The main being GKE. EKS was rumored at the time, but GKE was the one that came along. And it's hard not to look at them when you've spent all this time building up a metal installation, and then one bug can just devalue your whole proof of concept and your whole journey to that point. So we did begin looking at Kubernetes, managed Kubernetes. We're already trialing Google Cloud, as was Booking. It kind of ticks the same boxes. You can orchestrate it with Terraform without the need to go through the whole Kickstart dance. Masters do auto-upgrade, so you don't have to worry about security features. I'm going to say vulnerabilities is probably a better word. And it's easily scalable. So it did tick a lot of boxes that we had. We did have some power constraints and so on within one of our data centers at the time, which meant that we couldn't expand as rapidly as we wanted to into that data center. So it did tick a lot of boxes for us. But it's important to sort of highlight the journey to get there for us. So we started an OpenStack evaluation, which I think we realized that we could skip at this point. And then we started trialing, and I've put the the learning process in here as well, because I do think that's important. So we spent time on Kube Now, then we did Kubernetes the hard way, which is one of Kelsey Hightower's projects. And this is kind of how it manifested itself. So we had COPS within AWS for a part of the a project, a wider project to get everything to microservices properly, which then became COPS and EKS. We're still kind of at that stage now where we have one cluster within one region that's built on COPS, one cluster within another region that's built using EKS and Terraform. And the aim there is to go EKS multi-region, which we're not far from. Both clusters are there. We just need to put the traffic over and rebuild and Phoenix the other cluster. KubeSpray and bare metal. KubeSpray overall was pretty quick, pretty good. It's kind of terrifying seeing Ansible change so much when you build when you roll out, the same code. You think, oh, I'll just rerun it, and then everything's green, and you're not really sure what's changing. And there's so many lines, it's kind of hard to filter it down. KubeSpray and OpenStack, again, we didn't really go for the OpenStack route in the end, but that would have been quite cool. But the levels of complexity on top of one another is quite terrifying. GKA has been pretty flawless. The bugs that came out with the masters a few months ago, having them automatically patched is a really nice feature. You do have to do the nodes, but it's not so bad. And GKA multi-region is, we kind of have that already. We have a master tooling project that then controls all of the other Kubernetes clusters. So I'll hand over to Mike. The clicker doesn't work.
Yes, all right. So basically what Tristan's been saying there is that we spent a lot of time figuring out a bunch of different ways in order to bring Kubernetes up. We spent an inordinate amount of time actually getting really rather good at Phoenixing these clusters and getting up in that there, but that didn't really solve any of the problems that we really had. So what we wanted to do from these small beginnings was really sort of turn it all on its head. Making it easier for platform engineers to provide infrastructure doesn't actually solve the fact that your ops team is still a bottleneck, right? If you're going to be, whether you're writing a load of Terraform or whether you're going to be doing whatever, Puppet or whatever it is, it doesn't solve the problem. So managing large systems with large distributed systems with Terraform, it's still complex, and it can get very messy because everyone's got a different idea of what a good Terraform module looks like and everything like that. So really what we wanted to do was to just throw it all out and start again, to be honest. And what we wanted to do is, if we're going to focus 100% on developer experience, the four things that we wanted to do was to deliver velocity, business value, stability, and really gain adoption. So velocity, reduce the wait time to absolute zero for developers. Let them do it themselves. Strive for self-service. And business value, as soon as they can get going, they're off and running. Stability, less focus on looking after the Kubernetes infrastructure and more time on building tooling around it to make it feel like a more comprehensive platform for them to use. And then finally, adoption. We don't want to force people to use this platform. Now, historically, that's exactly what you would do, right? You buy VMware or you install OpenStack and you say, right, this is what you've got, guys, and we'll install this for you. We don't want to do that. We wanted to win people over to the new approach and encourage engineering standards along the way. So, get Kubernetes, any Kubernetes. At this point, we've done so many of them, it doesn't matter which type at the moment to us. We can, we're running GKE, EKS, Metal, infrastructure as a service. We really don't mind. And we're moving on to a CI tool. So we dog food our CI tool. We use the same thing that we give to our developers. In terms of CI, you spend a lot of time with your CI tool, so it's important to take one that you like. GoCD is the one that we picked. It's okay if you don't want to use any feature branching. It's got really nice support for pipelines as code, and if it's it was better than some others at the time in that space for us anyway. So we allowed users to have their own CI tool. So as in we'll deploy one per team or one per developer if they really want it. Kind of gets a little bit out of control that, but effectively the idea being use a GitOps model for your customers, allow them to get their own infrastructure, toggle the features that they can have, and their Git repo can become a single source of truth for getting their infrastructure and applications. So we've put this Gradle plugin together, which is kind of what our secret sauce and the glue code is. Not that much of it, really. But effectively, BG Cloud W is what we put together, and it's a wrapper and it's a bootstrap application that gives us environmental profiles. So if you want to have a default YAML and then have dev and test and prod and different configurations, maybe you want to hit a different DNS server for then, different set of features in one environment than the other. It templates the pipeline as code, so we give people some stuff out of the box for that. Configures all the platform features if you want, or some of the other things that we're going to go through in a little bit. And the ability to deploy any Helm chart through it. So the third thing that we did was observability. It's really key to any platform that's going forward. We've come a long way in the observability space at BookingGo. It's always been driven on front-end A/B experimentation at rental cars and Booking.com. Whenever you go to a page, you might see a green button rather than an orange button to try and encourage you to click next, and that's always been part of it. And we've always delivered that through things like Flume, Apache Flume, and Kafka, and it'll go into Hadoop or into a big MySQL cluster or something like that, and we'll crunch the data there. But our infrastructure monitoring estate definitely needed a refresh for the new approach. So what we looked at was Prometheus. Prometheus is fabulous, but when we've got about 15 clusters or something like that, maintaining a single pane of glass, it becomes a little bit more difficult, and actually having a HA version of it, I think one of the lads touched on that in one of the other talks, having HA Prometheus and being able to scale it up, it needs to be a bit more distributed, and otherwise it becomes a bit of a problem. So the way that we've done that is through this thing called Thanos, which effectively duplexes all of your Prometheus servers in every environment and deduplicates the data that it gets and filters it back up, and we point Grafana at the query thing in Thanos that gives us a single pane of glass. Actually, my colleague Tom Riley is not with us today, but he's got a fabulous talk about how we productionise Thanos and Prometheus, and we can probably share some links and slides to his talk, or maybe even get him up next time. The other thing was Elastic. Elastic's a big thing for us, so all of these things that I'm talking about here, by the way, are just, you get, if it's right to stand it out, it goes into these things. So if any pod that's right into the right place will come out and go straight into our metrics and logging solutions. So moving on from that, alerting. So we've got use an alert manager with Prometheus to configure things like Slack, PagerDuty, so we can get woken up at night like everybody else. Secrets. So management of secrets has been a bit of a sore point in the past. Developers committing secrets into GitLab. We just didn't want to propagate that this time. We thought, right, line in the sand, no more. You're not going to put in database credentials into your GitLab repository. We're not going to do that anymore. So we embarked upon a big project to design a front-end system for managing our secrets. Self-service portal is what we call it. It allows a developer to manage their secrets across all of their environments. They never need to share one with a sysadmin or anything like that. They just they can do it all themselves. And this is encrypted at rest with Vault and mounts via an init container. I think if you've got any questions, Tristan built a fair chunk of that, so he can probably answer some of those. And then one of the other things that we're looking at the moment is open tracing. We're really interested in this. It's popular with the developers, and they're all keen to try it out. I've got a bit of a demo of that shortly. I've got 10 minutes, right? Okay. But yeah, so we've made it very easy for our devs to actually get started very quickly. So what's next? We're thinking service mesh, Envoy probably, or Linkerd. Control plane's currently what we're arguing about. So whether it's Istio or a home-built solution, because we've got quite a few different sources of truth to bring together. Multiple region failovers, integration with our traditional data center stuff. Not going to seriously be done without some sort of service mesh. again, DBA as a service. I've been looking at the Vitesse project to see if we can get something useful going on there. Okay, so the core platform for us needs to be secure, highly available, managed properly. But in our case, it became clear that we didn't want to just give devs kubectl and let them get on with it. It just ended up with more mess. So creating a rich environment and automating around tooling really opened up the capabilities and drove far more value than just the underlying infrastructure. So it just became a more complete platform for us. So one thing that I would say is if you love it, brand it. We've called ours BookingGo Cloud. Devs love laptop decals, so if you've done some great work, tell them about it. Shout out to the rest of the business, because often what you'll get is they don't really know what you're doing. So, they don't know what you do for them. Aim for self-service. Zero support's the goal. Lazy sysadmins at heart, I suppose. And we built a community around it. So actually get Slack groups and Stack Overflow type Q&A portals, that kind of thing, and guilds for your power users to get together. And win hearts and minds. So customers want to get on the platform. Right? They want to use it. It's night and day from waiting 6 weeks for a server that's been puppeted up in their environment. Prevents project managers getting on everyone's back. So yeah. So our outcome is that we've smashed it, to be fair, in terms of getting applications onto the platform. We're really pleased with it. People like to use it. Got a really good developer community around it. In terms of adoption, we've smashed it 3 quarters running. So we're quite pleased. Maybe, should we try the demo?
Let's give it a go.
So if I go a bit silent here, Tristan's going to fill the void. Yeah, maybe, yeah. So I'll try and explain what I'm doing though. Hopefully we can maybe have to squint. But as I say, for each individual project, we've run a GitOps model. So what happens is they have all their code and all the gubbins and stuff. So it's just a Spring Boot application, what I've got here right now. But yes, I use Nano because I'm insane. It's miles better than Vim, but let's not start that here. So this is what I'm still talking about, right? So for every bit of the platform that we've exposed to developers, they can handle per project their own scaling situation, what their CPU targets are, where their health endpoints are, whether they're connecting metrics or not, what their application config is, what their memory limits are and CPU and whatnot, whether it's got an ingress controller and whether it's got secret service enabled and things. What I'll try now though is we'll go enable open tracing and take a bit of a look at that. So I've just made a commit to my repo. We've got this CI tool here, which is GoCD. I don't know whether you can see all of that. I'll try and make it as big as I can. And we've got a few things in there at the moment, stuff going on. But I need to add my project to it. But I don't want to go and have to tell my sysadmin to go and do that for me. So I'm just going to run this command that we provide for everybody. And this is LDAP based. So hopefully this will come up. We'll be able to find our. Can take a minute. Come up. It's not that one. There we go. It's actually triggered itself. You can encourage it if you want, but if you get there in time. So all we're going to do is we're going to build the app from scratch, deploy it straight out to dev, and then should see some of the open tracing work. legend comes up.
Yeah, this is where Java development is just fantastic.
Can I ask a question?
Yeah, of course, yeah. Please wait. Yeah, sure.
Perfect.
So 2 questions, actually. First one was how you're handling quotas.
Mm-hmm.
And then the second one was, why have you got a manual step in to add it to the CI pipeline?
Well, the CI needs to know about it. So as new projects come up all of the time, we have got all you need to, for starters, is to build.
So that's a one-off step.
It's a one-off step. For the very first time you add your projects in forever, there's no manual steps.
Right.
After that, if I want to make a subsequent change, you just make git things, it'll just pick it up, and that's all down to your, what your pipeline actually looks like. So if we look at things like CI, go CD, YAML, you'll see like our build is all YAML based, looks like, goes through and it'll run through each environment to that, like that. So, and what you can do is you can have it run dev and then go to test if it succeeds in test or whatever, and have a manual approval step for each one. So I've actually stopped this particular one at test, so it doesn't try and deploy any further. But hopefully we can get through very quickly. Doesn't normally take more than a couple of minutes. Sorry, you said there was 2 questions. Did I answer both those?
Quotas.
Oh, quotas. We're not really enforcing quotas other than we give people a namespace. So, and the namespaces will have an amount of quota associated with those. Again, with us being an enterprise, we're not going to rigorously enforce, the fact that a dev team can't expand to what they are. It's not like we haven't got like external customers coming in for that. It's more.
So you haven't had anyone eat all the resources yet?
We have. Yeah, we have people. We definitely have. Yeah, and I think it's mainly just through lack of understanding that they don't need all those resources, or they've got an inappropriate workload that's going on the system and stuff. So, this is not going to finish building, I think. Oh, it's just going out to dev now.
It's quite a large learning curve as well, I think, for devs to go from just having a VM that we size for them to them setting their own limits and requests as well. And getting the understanding there as well for them is because it doesn't work in the same way where you just set like requests and limits. It's quite hard to get your head around if you're coming from it from nowhere. With that as well, there's also a BG Cloud Gradle file where we set the URL, so you'll get given a GoCD server, that's your entrance to the platform, and they'll put that in your bgcloudw.gradle file, and that will go away, and that's your target for your GoCD server. That's how we define which GoCD server is per product team, in this case.
It's just taking forever to... Let's see if we can get it anyway, though. It's already deployed. So in Jaeger, if we've enabled our... so make the change in that. Yeah. We run a curl against Jaeger. What my application actually does is tell a really crap joke. But what we should be able to see now is some of the traces that have come through from it. The wrong one. So as you can see, like the tags go through, so you can just essentially set a header in your request, send through and you actually get the header that we actually put in the first place. Sorry, I don't know if you can see that. So there's a lot of things that you can actually do there. Now, if you look at this, I'll wrap it up. But if you look at the same sort of thing in production, you can make that really quite elaborate. If you enable that tracing throughout your system and throughout the multiple applications that you've got, you can actually track your single request all the way through to completion, or not, as the case may be. But so basically, without wanting to go on too much, don't just focus on the infrastructure, focus on the tooling as well, because the customers are all, and the developers are the ones that are consuming this, and if you give them a really great experience, they'll help you, tell you what you need to work on to go forward. Well, yeah, thanks very much, guys. Hopefully That's enough.